All right, so we are still talking about translations in the coordinate plane. And we were trying to make this jump, not really a jump, but this connection maybe between what we see in a graph, the translations that's occurring on a coordinate plane, along with what's happening to the ordered pairs so we can put it in coordinate notation. So it says record the coordinates of the pre-image and image in the table below. So this is a good time to talk about pre-image and image. Okay, how do we tell which one's which? And this is important. A pre-image is our original. Okay, they are the regular vertices, the letters without the little prime symbol, the apostrophe. Image figures are going to be the prime ones, right? And the prime is the apostrophe. So this right here is our pre-image, G-H-I-J. So our pre-image, G, we're just going to list this point right here. This is the point 2, because we always give our x coordinate first, 2, -7. H, now there's nothing that says you kind of have to go in alphabetical order. It's just easier and it flows better, I think, if you do. So that's why I always try to do it that way. H occurs at the point 2, -1. I, 5, -1. And J is happening at 5, -7. Okay, and then let's talk about our image now. Again, these are images because they have this little prime number here, right? Okay, so G is going to correspond to G prime, and G prime is happening at -5, -3. H prime is at the vertice, or at the ordered pair, -5, 3. +3 in this case. And then I prime is at -2, 3. And J prime is occurring at -2, -3. Okay, so again, what are we doing to this point to get to this point? This point to get to this point. So a verbal description, what are we doing? What are we doing to G? To go from here to here, what are we doing? Okay, well, and that's why it's important to recognize which one's your pre-image and your image, otherwise you're moving the wrong direction. So I know I'm moving to the left. Okay, how many units? Well, you can count it, right? 1, 2, 3, 4, 5, 6, 7. So we could say 7 units left. And, because we're not done yet, 1, 2, 3, 4. 4 units up. Now, does that work for all of them? Well, if I can go here, let's try I. 7 units left. 1, 2, 3, 4, 5, 6, 7. 4 units up. 1, 2, 3, 4. Okay, so I can do all these points, but it works for all of them because remember, a translation is going to occur the same direction, same distance. Now, our algebraic representation is that coordinate notation. So what are we doing to our points? Now, to our ordered pairs. Our x coordinate is our left and right movement. Okay, since we're going 7 units left, left is the negative direction. To go from 2 to -5, I am going to subtract 7. What are we doing to y? Okay, well, if I'm at -7 and I'm going to -3, I'm adding 4. I'm going up 4. Up is the positive direction. So this is y plus 4. There we go. Okay, that's our algebraic representation. So what do we notice about the line segments in the pre-image and image? Well, remember, it's a basic, translations are a basic rigid motion or a isometry. So if I looked at this segment right here from H to G, that would be 1, 2, 3, 4, 5, 6. I'm sorry, that's H prime, G prime. If I did this one over here, H to G, how many units do you think it is? 1, 2, 3, 4, 5, 6. The line segments stay the same, okay? So what we're going to say is the line segments, and I'm going to actually use my drawing tool here. Goodness gracious. The line segments are congruent. Now remember, congruent is the geometry word for equal. They're the same. They're the same measure. They have the same measure. Okay? All right, let's look at this next one. We're going to do the same thing we did before. We're going to identify our pre-image and our image. And our pre-image is going to be in this one, right? Doesn't have the prime symbols. Look for the prime. I know that's where we end up. So K occurs at the point negative 7, 2. KL, so again, I'm moving in a different direction here, but I'm just doing alphabetically. Negative 2, positive 2. M is at negative 2, positive 7. And N is at negative 7, positive 7. So our image then is going to be the one with the primes. So K prime, where does K, or what does K correspond with? Well, K prime is going to occur at 2, negative 7. And then we have L prime, which is happening at positive 7, negative 7. And then we have M prime, which is at 7, negative 2. And N prime, which is at 2, negative 2. Okay, so our verbal description. Well, if you count it, okay, let's say I'm going from L to L prime, I'm going to move to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's cool about a coordinate plane is we have the lines. So I'm going right 9 and then down 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going right 9 and down 9. So my verbal description is going to say 9 units right and 9 units down. Okay, so our algebraic representation, remember our coordinate notation, left to right movement is the x. So I'm moving 9 units to the right. I'm adding 9. If I'm going from negative 7 to a positive 2, that's going to be plus 9. Negative 2 plus 9 is positive 7. And then our y is our up and down value. Okay, so if I'm going 9 units down, that's the negative value, right? That's a subtraction. So I'm going to say whatever y is, minus 9. Again, 2 minus 9 is negative 7. 7 minus 9 is negative 2. Okay. Now, what do we notice about the angle measures? All right, so if I looked here, and we had NKL, well, that looks like a right angle to me. Even though I can't necessarily draw the right angle sign, looks like a right angle. N prime, K prime, L prime, guess what that is? It's a right angle, okay? The angle measures aren't going to change. Remember, it doesn't get any bigger, it doesn't get any smaller. So we're going to say the angle measures are congruent, equal. Okay? So, real quick now, let's describe this translation. Pay attention, we're going from m to m prime here to our x values. I'm going from 12 to negative 1. Think of it up here. I know I don't think these are big enough, but if I'm over here at 12 and I'm going to negative 1, it means I'm moving left. How many units left am I moving? Well, 12 to negative 1, you go 12 to 0, that's 12, and one more is 13. So we're moving 13 units left, and now check out our y values here. We're going from 7 to 14. Well, that's easy, right? What do you do to 7 to get to 14? You add 7. So that's 7 up, because adding 7 is moving in the positive direction. Okay, how about this one? If I'm at negative 6 and I go to negative 5, what do I do to negative 6 to get to negative 5? Move 1 to the right. Or I add 1. Now, what do I do to negative 8 to get to negative 2? Or I'm sorry, get to positive 2. What do I add to negative 8 to get to 2? I add 10, which would mean we'd move 10 units up. And the last one, okay, O and O prime here. What do I do to -3 to get to -9? Well, if I think of it on the number line, I think I'm going left 6. Or I know I'm subtracting 6, which would mean left. So we're moving 6 units left. And what do I do to 6 to get -1? Well, if I'm at 6, I'm dropping down to -1. Or I'm subtracting 7. So I'm going 7 units down. Okay. Big thing is, guys, to make sure that you're matching up your x's to your x values and your y's to your y's. Okay. All right. Last thing for the summary, just a couple things, and I want to focus right here. Right. I want you to say this: translations are what is called distance preserving. We preserve something, we keep it the same, right? We try to keep it the same. So we say distance preserving, right? And I'm going to switch it around here. Maybe I should have done the first one, but that's okay. I'm going to say, no, we'll just say this, angle measure. I was going to say preserves angle measures, but we'll just say angle measure preserving. That's going to be important to know later, right? If it's a translation, standardized test. Hey, this the segment is 5 centimeters. You translate it. What's a new segment length? 5 centimeters. Why? Because translations preserve distances and angle measures.